Hello, how are we doing? Better. Good. Okay, welcome. My name is Joe Hellerstein, and I'm here to speak about big data wrangling and getting down to business. I wear two hats, actually. So I'm a professor at the University of California, Berkeley. I'm a computer scientist. I've been there since the mid-90s. My research area is in data management. I've been working in the area for a long time. And some years ago, we took some research off of campus, a collaboration I was doing with folks at Stanford, and created a company called Trifacta. Trifacta is the leading solution for data wrangling in the world. We've been around for about 4 years, and we have customers all over the world, particularly here in Europe as well. So today, what I'd like to do is give you a bit of an outline of what's going to happen. If you know anything about Berkeley, where I live, you know it's sort of an activist town, so we'll frame the talk in those terms. We'll start by talking about bringing data to the people, which is actually the name of the research project that led to the birth of Trifacta. Talk about celebrating diversity, and I'll tell you what I mean by that when we're talking about big data and business. And finally, talk about the technology challenges in bringing the function and power that's possible with data to a much broader audience, particularly to business users. So that's going to be the focus of today's talk. So many of you have probably been talking in your organizations about data lakes, and you've seen these lovely images, visions of the future. The reason to think about data lakes is to provide a common platform for a variety of business functions and organizations to gather together around a single technology space and a single repository for data. And you know, the exciting opportunity here is to really get these diverse functions working in a single context and sharing knowledge, sharing information across them. Now, if you go talk to your business users about the data lake, they probably often feel that it's a bit more like this. That it's, they're frozen out of really using this technology. They don't even know what data is in there worth fishing for because it's a very technical environment. Right? Data lakes today are still highly technical big data solutions based on things like Hadoop and Spark. Wonderful stuff that came out of places like UC Berkeley, but not necessarily originally targeted for business users. And when you think about the population in your organizations, you know, there's an exponential distribution in this population of the number of people in these more to less technical functions. So as we go from the left-hand side of this axis, the sort of pure keyboard users, to the right-hand side of the axis, the pure mouse users, you know, you see sort of exponential numbers of an increase in the number of people in your organization who do these functions. Very few data scientists in most organizations, somewhat more data engineers. You may have a group of people who are good with SQL if they have their data in a single database. And then, of course, a large population of Excel data analysts and business users. And this is just the way of the world, and it's a reality that technologists, I'm sorry to say, haven't been addressing very well in the big data space up till fairly recently. At the same time, when you look at data volumes or the accessibility of these people to data, it has the opposite distribution. People on the left-hand side, the sort of rarefied folks, have access to petabytes and terabytes. But as you move right, we're into the megabytes, gigabytes, and kilobytes. So, you know, to speak technically, there's an inverse correlation between the number of people who have access to the data and the amount of data those people have access to. And this is not a good state of affairs at all. Okay? So this is not the way we wanted things to be. And it ends up letting your business users feel a bit like this. They're in sort of the data kiddie pool rather than the data lake, right? They've got a small amount of data that's been carefully curated for them and produced in these little marts or spreadsheets. And that can be fun for a bit, but it's rather limiting, right? And over time, they grow out of this, and they really want to be able to do their own work. Okay, so you know, the first sort of message I wanted to get across and tee up the technical challenge around it is that we really want to put the data in the hands of the people who know it best. The people who are going to make use of the data and generate value for your organization are the people on the right-hand side here, the people who are closest to the business functions, closest to the use cases. And we have to empower those people to get access to data and to have the ability to work with that data in volume at scale. Right, so this is really the framing for how we were doing research at Berkeley in the Data to the People project, and it's the framing for the Trifacta product offering as well. So in that context, I want to talk a bit about diversity. So what do we mean when we talk about business users? We actually mean something rather different than we used to. So there was a time, and I was around at this time as well, so we used to work on things like this, where data warehousing was sort of the word of the day. And the idea was that you had a carefully curated, almost tightly guarded, really, repository of data that was a key asset to the business. It was the single source of truth in the enterprise, and it was expensive to build and important to maintain at quality. People would talk about master data or the golden master of data, right? So this was a highly prized resource, and it was carefully guarded by the IT department on behalf of executive decision making. And when you read sort of the leaders of the data warehousing movement in their books, they'll say things like this. Bill Inman said, "There's no point in bringing data into the data warehouse environment without integrating it. There's no point." Okay? And this almost sounds crazy today. It's not that many years ago, actually, that he wrote this in a book. It was after 2000. But the idea that we would push data away, that we should shield ourselves from bad data, was really very deeply ingrained. And you see it in the name of the book, sort of in the very sort of framing of the whole argument, is that we're building a data warehouse. It's an architected environment. It is a fortress, okay? And building this thing, therefore, has to be done very carefully. It's very much tied to the whole sort of 1990s and previous notion of waterfall design. Right? We take a long time to design and plan and ensure before you actually deliver value. And as we know, this is sort of not considered to be the best way to work with data today, because it's wonderful to have a fortress on a waterfall, but most of the time this is more of a vision than a reality, right? So by the time you try to deliver one of these projects, it's really turned into fantasy. Now, there are data warehouses that are extremely valuable to the day-to-day function of business, but by volume and by value potential, those data warehouses will be swamped by big data projects over time, because they are bottom line accountancy functions, critical to the business, right? But they're not going to grow substantially over time, and they're not going to deliver new value to organizations. Really, we need a different paradigm that's much more empowering to move forward and to generate top-line value from data. And that's why we're here. Okay? That's why we're having our conversation today. So the data lake is supposed to be this environment. And we're in the early innings, if you will, to use an American analogy. We're in the early innings of the game to make data lakes really useful. All right? So let me give you an example of how data lakes are useful. And it's not merely that they're accessible. It's also that they foster diversity. It's not a single source of truth. In fact, it's many different perspectives on the same data, many different views of the same data. There isn't one truth in an organization. There's relativistic truths depending on how you look at things and what your business function is. So a concrete example, PepsiCo is one of our customers, and they have a wonderful use case where they brought in Trifacta to save them nearly all days of the month. So some 70, 80% of their time is saved now in doing supply chain work. So this is inventory management. Pepsi obviously delivers products, snacks, and sodas to many supermarket grocery chains and other outlets. And they want to know, for each one of these large outlets, how much product to deliver to which stores each month. And it's important that they deliver just enough, because if they deliver too little, they've lost revenue opportunity. And if they deliver too much, they get returns, which is spoilage and is waste. So every month they have a process to try to figure out what's the right volume to deliver to each store. And that process used to take them nearly the entire month to do, and now they can do it in a day or two using Trifacta. Okay, and this is a scenario where this business function was not part of IT. It was not done by highly technical people. It was done by people who were working with access databases, spreadsheets, and getting the job done as best they could. But really, they needed a new tool chain to empower them and make them much more efficient. Now, in that organization, there's also other functions, obviously, that can take advantage of the point of sales data that's being used right now in inventory management. So another example would be customer satisfaction. It would be nice to take that point of sales data and aggregate it in ways where you could correlate it with social media campaigns. So you could figure out in a particular market, let's say geographically, whether sales were up or down relative to what you might see in social media. So that's interesting from a customer behavior perspective to try to figure out what people are doing in different sectors. Similarly, in a marketing setting, brand management is important. Pepsi has many different brands, and they're targeted at different demographics. So you might want to look at point of sales data and see how it correlates with things like demographic data that you can buy from third parties or political data that you can buy from news outlets, right? So you're taking in each one of these cases a different view of the core data in the lake, bringing in new resources, both from social and from third parties, into that environment and integrating them together. And there's not a single source of truth here because the functions that these people are doing are so different. They may, for example, exclude different data from their analyses for different reasons, right? Their notion of what's noise and what's garbage and what's truth might depend on their use case. Okay, so we try to foster in a modern, more agile environment a very diverse notion of what could be useful to the analyst. So the second message I'd like folks to take away in the big data context is to move beyond the notion of a single source of truth or a golden master, because that inevitably limits you to a very conservative notion of what data could be used for, and it leads you to a conservative notion of what's possible for your organization to achieve. Okay, so the third topic is the one for me as a technologist that follows in as the most interesting of these, which is how do you solve this problem of the inverse correlation between data volume and skills, right? And really, this is a question about how can computers help people be higher functioning, right, with data. It's a real basic question of how can technology help people. And that's why we got into this business to begin with. So if what we're trying to do is let data-driven business people make data-driven decisions and drive more value that way, we're going to have to make this whole process of getting that data to that stage more efficient. All right? This involves discovering what data you have on ingestion, structuring that data, cleaning it, enriching it, and blending it with data from other sources, and then optimizing and publishing it for use. And when you talk to analysts, as we did when we started the research on campus, and as we continue to do, obviously, in the field at Trifecta, you hear over and over that 80% of the time, 80% of the actual work that is done with data is done in these first stages, and 20% of the time is done in the actual analytics, reporting, and visualization. Okay? So if you actually care about how people work with data, if you actually want to solve problems on day-to-day business use of data, these are the key problems to solve. This is where we want to bring technology from research institutions and from big ideas in the industry and apply them to real-world problems. So this has been our mission in our research and in our company for the last 5 years or so. So, we began the process by asking why are business users disconnected from this big data? What's preventing them from working with this data? And the answer is really quite simple. When you look at the tools that people are trying to suggest people use for big data, they're programming environments, right? So things like Python and R. So there's a library in Python called Pandas. How many of you have used Pandas? Okay, a couple. And how many of you have used Plier or dplyr? So the same hand is up, right? So there's a couple technical people, and this is sort of the state of the art in the big data sort of data scientist community. And I'm sorry, as a computer scientist, these are not particularly exciting technologies. They're just scripting languages. For those of you who've been in the industry, they look a lot like SAS data step. Okay, which is what you would do this in 15 years ago in a commercial product. They're just simple scripting languages, rather complex and unpleasant to use, and most business users can't use them at all. So there is visual technology, if you will, from the 1990s in the ETL environment, right? So this is, what you're seeing here is actually turn-of-the-century user interface. This is a screenshot from an Informatica website that was archived by the Internet Archive around 2002. It was the oldest resource I could find. Okay, on the web. And this is the Informatica user interface, which is visual to a degree and looks quite a lot like many of the user interfaces you'll see in the products on the floor today. Okay, this is still sort of the main user modality that's being provided by vendors for working with data. It's got a kind of schemas and annotations basis. So you bring in data that you assume is already structured. You don't look at the data, mind you. You look at the descriptions of the data, look at the column names and the types. And then you provide mappings and functions to take those descriptions of data and put them through code to generate other descriptions of data. And if you have that all right, you run a batch job and you look at your output. So there's so many things about this that puzzle me. First of all, if you zoom in on this user interface, and I'm sorry the screen resolution isn't so good, what you'll see is that for every one of those little boxes on that diagram, there's an incredibly complex set of tabs and drop-downs to fill it in. Essentially, a box is like a command in Pandas or dplyr, and all these drop-downs and panels are the arguments to that command. You're basically programming here. Right? It happens that rather than typing the name of the command, you drag it onto a canvas. And it happens that rather than typing the words after the command, you pick them off of these panels. But it's still absolutely programming, and it's quite technical. A second problem I have with this is you're not looking at data as you go. If you build a multi-step pipeline here, you actually have no sense as to whether this cascade of steps is, one step at a time, doing what you want. You're getting no feedback till you run this whole job as a batch execution. So it's a very sort of archaic, sort of, removed environment from your data. This does not look like data analytics tools. You're not actually seeing your data at all. So we worked on this in the early 2000s. This is 15 years ago. I had some students at Berkeley working on how can we build a more interactive, higher feedback visual environment for data transformation. And we built a tool called Potter's Wheel with the metaphor and notion that data should be like clay on the wheel, and you should be shaping it and molding it and getting feedback as you go to try to produce outputs. So there was a spreadsheet metaphor. And it would start sampling data from a large data set and streaming it into the UI. And as that data would stream into this sort of growing spreadsheet, you could apply these menu-driven transformations and get immediate feedback. And the language for transformation was chosen carefully from the research literature and adapted to the task. Okay, so if you're interested in the paper, I'd encourage you to read it. It's still widely cited. And that was nice. And there are now products that look very much like this, I'm pleased to say. What was a limitation of this, and remember this is now 15 years ago, 2001, is that you're still really programming here. Pulling down a menu item, getting a dialog box, and filling in all the parameters is once again programming. And so while this gave us the feedback we wanted, and it was very interactive in that sense, it really wasn't helping the person who might be less technical get access to the work they had to do with the data. So nice feedback, nice agility, but still relatively technical. Okay, and that is the state of play for most of the newer data transformation or data prep tools you'll see in the market today. Around 2011, we decided to revisit this problem. So a colleague of mine, Jeffrey Hare, who did his PhD at Berkeley, went on to become a professor at Stanford, wrote the D3 library, which some of you may use for data visualization. So leading person in data visualization. And I said, hey, Jeff, we have this problem on data wrangling. 10 years later, with advances in user experience and advances in AI, what can we do to help people do even better on these tasks? And so we introduced a number of new technologies in this data wrangler tool, which is available still actually at Stanford online if you want to play with it. The first we call Predictive Transformation, where the computer and the user participate together in the intelligence of deciding what to do with the data. Users highlight features of the data that look troubling or interesting. And the AI software recommends steps that the users can take on the data and shows previews of what would happen if they took those steps. So the user essentially is guiding the technology, guiding the data towards features of interest, and then being shown previews so they can decide which of the next steps is the most appropriate one. We call this the guide-decide loop. And it allows people to interact with the suggestion engine and see data visualizations of what would happen to their data as they go. So you got this immediate feedback. You had the predictive transformation. One of the downsides of this is it worked on just as much data as you could paste into a cut buffer in your web browser. So it was really a very, very small data solution, prototype research. So the tech challenge here was we want to make working with raw data at scale visual so that you can see what's in your data and use visualization to drive transformation. We want to make it intelligent, this guide-decide loop where there's AI algorithms in the background that are augmenting the task and saving you the trouble of programming, in essence. These are suggesting steps in a program to you and letting you evaluate output rather than generate the script input. Okay, so it's guide, decide rather than programming. We want to make them very interactive so that you're doing direct manipulation with the data, getting immediate feedback on how those transformations impact the data. And then at the end of the day, we wanted this to be delightful. We wanted you to be able to have aha moments as you're going through your data. I see what's going on here. This is how I have to fix it. Wow, I get it. I understand this data better than I did when I started, much better. And you'll find when you talk to people who work with data on a daily basis that during the wrangling process is really where they get deeply inside the data set and really understand what their assumptions are and how to shape the data to their assumptions to achieve their goals. Okay, so this is exactly the kind of experience you want your data scientists and your data analysts sort of on all scales of their technical skill to be engaged in. They should really be playing with the data when they're prepping it for analysis. Okay, so all of this led to the Trifacta product. The Trifacta product is quite a bit more advanced than the research prototypes. It's deeply visual. The interactive exploration goes along a number of dimensions so that you can see correlations between different dimensions. And it involves a bunch of different modalities of visualization that you can work with. Okay? It also has very powerful and intuitive predictive transformation. So every time you interact with a visual preview of the data or interact with the actual data rows themselves, you get suggestions in these cards down below as to what you can do with the data and previews of what would happen if you took those suggestions. And that's that guide decide loop that we talked about before, but it's very much in the eyes of the data analyst playing with their data. Okay, so in summary, we talked about sort of 3 themes today. We talked about bringing data to the people, so really lighting up all the nodes in your social network of data analysts in your organization. Not just the deeply technical people, but light up that whole network of people who should be working in a data-driven fashion. We talked about celebrating diversity, this idea that the single source of truth is a rather archaic view of how to manage data in a modern environment. We should not be pushing data away by any means. We should be trying to enable people to extract signal from noise and apply that signal to their problems. Okay, and then finally, we talked about some technical approaches that meld user experience modalities that are quite new, these sort of guide decide loops, with machine learning algorithms that can predict what people will want, perhaps not perfectly, which is why you need that sort of user interaction to be deeply tied to the intelligence of the algorithms. There's a 4th topic that we don't have time for today, which is how do we get context around this behavior across your organization? So how do you know what all those nodes in your social network of data analysts are doing? I gave another talk on this topic here in London back in May at the Strata conference, where I talked about data relativism. And I'd encourage you to go watch the talk on the web if you want to learn more about this. There's the address. You can just go to bit.ly's data relativism 16 link. Okay, so easy to remember. Take a photo if you like. So this talk frames kind of that journey building the data lake. And then finally, the other thing I want to mention, in my research group at Berkeley, back in the open source, we're building infrastructures to try to help gather that context that you might have across your organization for how people are working with data. So this is a system that we've been building, and it's called Ground. And I'd encourage you to have a look. Ground is actually a collaborative project, not just with Berkeley, but with a number of users, including Capital One, including LinkedIn, including Cloudera, and a number of other small Silicon Valley companies that are contributing programmer time. So this is a community effort to build a infrastructure for managing context and metadata within a big data context. Okay, and that's all I had today. We have a little bit of time, and I'm happy to take some questions. Thanks. Sure, right here.
Okay, I'm working on the smart strategy specialization. This is some kind of, let's say, European guideline for investment on projects. The question is, how do you link between the business and strategy?
How do you link between business and strategy? Wow, that's a question that goes outside the scope of data analytics, right?
So, I mean, all this technology, you want to implement in a practical way in linking strategy and business. How you do it? Because I think your talk is about from business to strategy.
Yeah, it's a great question. I think these things are best tackled one example at a time. And one of the things I think that's dangerous with viewing data lake projects as an overwhelming sort of full organizational effort is that you don't take the time to build these connections between people who are responsible for these different functions. So I always advocate if you want to sort of empower people and pull this off, that you start with projects where you know that you can connect the stakeholders and the technology pieces to get examples of value. So when we started with Pepsi, for example, the first use case was a single grocery chain in that single task of inventory management. And now we've got a dozen use cases or so going on in Pepsi using that data infrastructure. They now have Hadoop, they have Trifacta, and they're going after a number of other use cases. So going from tactical to strategic, one step at a time.
Yeah, can you talk a little bit more about why you were suggesting that you shouldn't worry about a single view of the truth? Because
yes,
everyone in the business is quoting a different sales figure, you know.
Good. And I'll say that, if you want to spend another half hour listening to me on that topic, that video I linked is all about that. So this is not, one of my goals here is to be a bit provocative, but the truth is that data warehouses are critical to business function. And having the single source of truth around tasks like reporting revenue is obviously something that absolutely required, right? I also, by the way, lived through the 80s and 90s in database technology, and there's a lot of good stuff there that hasn't even been developed yet in the big data stack. So I have deep respect for that whole technology space and its use cases. That said, the data warehousing industry as sort of an analyst industry was very focused on deep integration projects that would produce small, by today's standards, data warehouses for a single function for a very small set of use cases. There's so much available resource in terms of compute and in terms of data for other things we can do. I think it's really important for me and for the community to stir the pot and say, data warehouse, very nice, thank you very much. Please continue spending billions of dollars on that every year. It's very good. But there's so much more we can do on the top line to find value. And so that's really the message I'm trying to get across. And to do that, you have to empower these different views of the data, right? And people are not going to want it in the form that it's in the data warehouse. And they are going to want all that other data that Inman and others are saying, never, no, don't let that in. That's garbage in, garbage out, terrible stuff. Right? Oh my gosh, what happens on Twitter? That's terrible. That doesn't have a schema, and it's probably wrong. People are saying wrong things out there all the time. We take a very different view of that today than we did in the 90s.
Hi. How to avoid data overload in data lake when it comes to latency as well?
So great question. How do you avoid data overload in data lakes? I think my best answer to that is that people remain in the loop, that you really need to leverage the use cases and the value propositions that people are bringing to the table. So if you have an analyst who spent a month on a data set that they happen to have stored in the data lake, you want to know that. You want to extract from their head what particular things they did to what particular data sets, and you want to disseminate that information in the organization. Okay, it's not that you will understand every bit and every byte in your data lake, but rather that when people spend the time to invest in understanding a particular subset of the data in the lake, that value is extracted and shared across the organization. So how do we do that? Trifecta, for example, produces full and very detailed data lineage of all the steps that go from taking raw data, turning it into refined data. That data lineage is gold. Right? We publish that into our partners' data warehouse catalogs, so things like Cloudera Navigator, Hortonworks Atlas, and Ground, so that you can share that outside our tool and take advantage of it across the organization. And I think the next round of innovation, to be honest, in this space, now that we've lit up the nodes in the network of users, is to connect them and propagate information across them so that each person's work influences the way that other people can get value. So I think it's very incremental and it's very user-centric. I don't believe that this will be solved by having algorithms look at bits, because the bits have to be interpreted by use cases. All right, thanks so much. This was fun.